All right, so we realized that we have the wrong footprint. So what we want to do is download the new library, and then we want to, that's like it. No. And we want to import the new one, and we place it instead of the old one. All right. So once we're here, we're just going to have to move the have to move this guy, place a new capacitor, unpolarized, of course, the correct form factor. We just place it, let's say, over here. We connect this together, and then connect this, and we can name both of them ground. So ground, yes, and then ground, yes, and then what was it? We have, so we're making this port, but with a modification. So then we want to have the TX, which is over here. We want to connect TX to RB3. TP2. Okay. Let's see the schematic. Pin 13. PA3. RB3. Yeah. All right. Let's say, for example, that this is TX. This would be TX, and on this we have TX. Connect them together. Great. And then for the RX, this is over here. For RX, that's TB2, and that would be PA2. No? PA2. This one. PB3, yeah, there we go. There we go. There we go. Okay. So this is RX, and this is RX. Okay. So then the $13 should be 6. What do you mean? Yeah, so it's basically just the other way around, RX TX. Okay? Okay, that's fine. And then we just find a place for the LED, and then we just need to find a place for the button. So the button just goes from, let's say, this one, and then to ground as well. Yes, any objections? We can do it the other way around as well. We can also go from power in through the button and into the controller itself. It is a good, it can also be good practice to, it can be a good practice sometimes. So the microcontroller unit has something called a pull-down resistor, which means that it just has a current flow of electricity through it, but it just spikes the electricity up when you push the button. It does have that internally, but sometimes you need to do that externally as well. I'm not going to do it in this exercise, but just keep it in mind, something called a pull-down resistor. Once we have this ready over here, we go over and we go to, we go to the board. We switch to the board, we save this schematic, we switch to the board, and then we're prompted with something that looks like so. Now, here we have the footpaths of all our components. They just look kind of messy and such. We need to move them into the board. So this is the board that we're going to be working with. We can move this closer, which I do recommend. Just make your canvas, make your layout nice and neat for you to work with. You can do this afterwards as well. That's fine. What I'm going to show you then, once we've finished with this, is how we can modify this with Inkscape to get any format and any look that we feel is the most comfortable. But we just move this into our board like so. I'm just going to place this somewhere. This can be a little bit of a puzzle. This can take some time to figure out where it's nicest and neatest to place these little components. But once you get used to it, you get a feel for it. And what is also nice about this, what can also be nice about this, is you might want to use the old design like this one to figure out where you want the board, where you want it to actually be sort of kind of placed. So over here we have this board looking like this. So it's for example good practice to have the capacitor, on the upper corners here, because here we have both the grounds and then we have the power in. We can also place this somewhere over here, and we can use the gap in between the little button here to route traces through them. So number 1 and 2 are connected together, and 3 and 4 are connected together. Just FYI. So we could, instead of connecting this to number 4, we could rather connect it to number 3 if we wanted to. So that's quite fine. So now we just place it somewhere like so, and then we can go into something called tools, and we do an outer route. So we can use the program, use our program here to outer route for us. We can use it to help us to find the best paths for everything. So we just do continue and start, and then it'll make some kinds of routes for us. It'll route the paths for us, which is kind of nice. Actually, thinking about it, I'm not sure that it did add the design rules. Design rules. Yeah. Load. And equal Fab design rules. Open. And apply. Yeah. And then we go tools and outer route. Continue. Yes. Save. Yes. You can get them on the same webpage as before. Tools, outer route. Yeah. Actually, did design rules. Load. Tools. Outer route. And sort. Okay, there we go. Okay. Nice. So end job. So this, it looks like outer root was successful with us. We don't need to modify this at all. There's no jumper wires, there are no cables that are not connected. Everything looks kind of fine. We can, however, if we really wanted to, we can move the vias here. So we can move the roots, and we can lay them out however we kind of want them to. One thing to which because you can see that it jumps a little bit. It has some intervals that it prefers. We can change that by going into edit, and then grid, and we can in the grid we can change this obviously to millimeters if we wanted to. This is the jump that it's going to take, and we can take this to say 0.5 millimeters, and then we have a much smoother. You should have it much smoother. This 0.1. Yeah, you can see how it becomes really smooth. We can also change this from preserved angles, so 45 degrees angles essentially, to free angles, and then we can just take this any way we want it to. So this is kind of nice. We have everything ready here, and sometimes we do need to add jumper wires and jumper cables to this, which is quite fine. Sometimes we'd prefer to have it multi-layered or whatever. But for this exercise, this should be satisfactory. Do not take this as a rule of law. There is possible that something is wrong here. So just do your own research before you actually do decide to mill this PCB, and then obviously let us know if there's anything wrong with this file. Either way, so once we have this ready and set up. What we can do is we can select the ones that we don't really want to see. So we can say that we only want to see the top layers. So actually, selection filter. No, that was not the one. Layer setting. Yeah. So we can say hide all layers except for the top ones, except for the ones that we want to see. So this is the traces. These are the roots that we want to see on the board. We don't see the components, the pads. Let's see the let's say shield layers. Yeah, so we don't see the components. We don't want the components to show. We only want to see the the roots that we're going to take. So okay, and we can now take this. We can take this entire thing, and we can export it as an image. And then we want to have it monochrome. We want to make sure that it's monochrome, and it's good to have it something like 1500 dots per inch DPI, because we really want this to be high resolution. We can just call this a test board, and then we take the full area, okay, and then this gets saved into usually documents, Eagle, and then projects, testing, and now I should have the testboard.png, which is over here. And if it loads, so now it looks like this. So now we have a PNG, a very high resolution PNG image of just the traces that we want. Now, when I was learning this, Bas actually told us how to use this, and then export this directly into, let's say, Fab modules, for example. What I'm much more interested in is using Inkscape to modify this the way I want it to. So I can root the layers, and then I can have any shape that I really want as the outlines of the board, which I feel like is way more interesting. So I can import this board over here, I have it like so. And then there are two things that I really want. So one of them is the routes. I really want the routes, and then I really want something that goes over and designates what is actually going to be cut out of the stock that we're going to be milling from. One sweet way that I really like is just to trace the bitmap. Okay. And then I get a vector image of the very same thing. And then I really don't need to use the old one. We just discarded it for here or now. And then I can take another stencil. I want this to go to the bottom. And then now I have an outline from this. What I could, for example, do now is I can say path and difference, and then I only have the paths available. Now I can make a little guy or a little figurine or something that I can actually take these traces and I can import them into the image. I could use the LED as eyes, or I could use the button as a whatever. But with this feature, which you can also do with Fusion, mind you, you can also import the schematic into Fusion and get a 3D design of the files. You can really start to tinker with the PCB as art. You can use it as something that has more than just a static box. But either way, instead of actually exporting the outlines of the board, I just like to take a box. I just like to take a box. I make a circle. Now this is the board, and now I also have a box that I can use as the. I also have something that I can use as the cutout file. So I just like to make a box like so. Then I can transfer this. I can say that this is supposed to be white and the other one is supposed to be black. This goes to the bottom. And then I have something that is of the same size, and we have to really be careful to have the outlines. This is where the big mill is going to mill. This is where the small mill is going to mill. We have to make sure that they're the same size, because otherwise we might cut into the traces. So now I can take this file and I can export it as PNG, export PNG image, and I want to keep it the same pixels, so 1500. I do have to make sure that sometimes if you export this into Inkscape, you have to make sure that there's no discrepancy in the size of there's no scalability. Nothing has scaled up and down. You can do that, for example, by measuring manually, like so. You can measure the component. It's around 16. I know that this component is supposed to be about 16.5 millimeters in height. So I know that there's no scalability. There shouldn't be any discrepancy in, like if there is a scalability issue, it should be massive. It should be either 10 times too big or 10 times too small. If it's like within one fraction of a millimeter, then you shouldn't have any scalability issues, at least in my experience. Now you can take this, you can export this as testing ready traces. Having it 1500 dpi or 1000 dpi or even 500 dpi for such a very basic board, it shouldn't really matter that much. It's mostly about the resolution of it. If you have a very complex board and you have a very slow computer, you might get a calculation difficulty. Like it's mostly in terms of the size of the image rather than the details of the image. So we can export this into my, let's say, just desktop, and then save this over here, export, and then we want to save this as testing ready outline, and we export this on the desktop as well, and then we should have everything ready for milling. Then we go about, we mill this stuff like we did with the electronics production. First we do the layers inside, then we do the outlines outside, and then we want to program it. Yeah, there's one thing that I forgot about this. Yeah, we're missing ground and voltage input over here, and we're missing ground. Yeah, this is the FTDI. Sorry. Okay, I'm gonna stop recording.